So we can also test the difference between two dependent samples. So dependent samples, this is where the two populations are definitely related. So it's either the same person you're doing two, or you're testing twice, or maybe it's some sort of paired, like twins or siblings or a married couple. So something where there's a definite relationship between the two values. And you can see if there's a difference between, right, the two things. So pre-post test, mean cholesterol level changes with the addition of medication. Maybe you could do the pulse rate of a husband versus the pulse rate of a wife. We could do right, that sort of thing. So what we're going to do is a t-test on the differences. So I'm going to do this entirely in my calculator. So here are the keystrokes. You have a set. So we're going to put in one set of our data. So one of the pairs, right? All of their values go in list 1, and the other is going to go into list 2. I need to make sure they're across from one another. As you can kind of see the example down here, we're going to test twin A and twin B. So I just need to make sure that when I input them, that 87 is across from the 83, that 92 is across from the 99, and so forth. Okay, so we're going to get, so I'll go ahead and list down here. I'm going to put twin A in list 1 and twin B in list 2. Okay, back up here. So once we get them input, then we're going to clear out L3. I need to make myself some space. And then there's this awesome thing. I can go ahead and have my calculator do the subtraction. So we're actually going to do the difference between these two values. Okay? And then we do a t-test. So stat test, and then the t-test is going to be on L3, which is that difference. So is there a difference between twin A and twin B? So this difference is going to go in L3, and I'll do a couple just so you know what's going to happen. So L3 is going to get populated with 87 minus 83. So that'll be a 4 that we'll see in that first line on L3. 92 minus 95, that's negative 3. Okay, and so forth down the line. Now I'm not going to go ahead and fill that in because I don't really care what those individual values are. We're just going to test the mean of that row that we're going to find, a column on our calculator. So the hypotheses for these, so the null hypothesis is that the difference is 0. Okay, that L1 and L2, twin A and twin B, they have the same, pulse rates. Okay, there's no difference in the pulse rates of twin A and twin B. And then the alternative, let's see, is there a significant, so again, it's just difference. So we'll say mu sub D not equal to 0. I could imagine a time when you would have a specific inequality in there, and that would be totally fine. Maybe you think that the men's heart rate or pulse rate would be less than the women's pulse rate, so then you'd have your inequality going in that direction. You'd have to pay attention up here, right? If it's not a not equal to, right, then you're going to want to pay attention to how you subtract. So I'm just going to, quick little side, sorry, stop, come up here. So L1 equals L2, right? That's where we're going to start. If we think that L1 is greater, so let's just say we think that L1 has the greater pulse rate, then we would think that L1 is greater than L2. It's not for this one, this is for some hypothetical other one, so you know how to do this inequality. So then, if we have in our L3, L1, subtract L2 from both sides, minus L2, then that says that that difference should be greater than 0. So you would say that L3, your alternative hypothesis, would be greater than 0. So just kind of trying to read those and get the inequality symbol going in the right way on these can be hard. So I really recommend, if you have one that's not just a difference, that you start with this, right, inequality comparing your two L1 and L2 values, and then figure out how you're going to subtract in your L3 and then that will determine the symbol that goes in your alternative hypothesis. Okay, we lucked out and ours is just a difference, so here we go. Let's go ahead and follow those steps now that I'm back on track. So we need to go to our stat and edit some lists. So we'll clear out L1 and L2, and so arrow over, arrow up, so I'm highlighted on top, clear and enter. L1 gets twin A. And L2 gets twin B, right across from each other. And so now here's the next step. So clear, so L3 is clear, so I'm going to go up to the top. So I'm highlighted up here. And then down here at the bottom, I don't know if you can see, it says L3 equals. So now what I wanted to do is I decided I'm going to go L1 minus L2. So your L's are down here on the number pad. So right above the 1, up and to the left, it says L1, and it's in blue. So to get that, I do the blue key first, and then the number 1. And now you can see right there, it has L3 equals L1. But what I really want is L1 minus L2. So I'm going to use the subtract key, and then L2. And as soon as I hit enter, the calculator is going to go ahead and populate list 3 with those differences, right? And it did the first 2, and they, of course, match. Okay, so we have L3, so now we do a stat test on a t-test for that L3. So stat, test, t-test, and now we have data. Mu naught, right? That's a 0. And the list is L3. So remember how you find your lists. So second and then the number 3. I don't have a frequency, and I am doing a not equal, so I can leave that there. And calculate, and there is all of our information. So the average difference, so X from our sample, so X bar, average of the sample of the differences is 1.25. Is that far enough away from 0? Well, the p-value that we got is 0.36. That's a pretty big p-value, right? This is much bigger than alpha. So our decision would be do not reject H naught. So we're not going to reject the null hypothesis. There is not a difference, right? So summary, there is not enough evidence to support our claim the average pulse rate, sorry about that, is different. Okay. So even though it's, right, the difference is 1.25, it's only 1.25, right? That is not big enough to say that the difference, right, that there's a difference.